Hello students, welcome back to our class. We were discussing the lesson structure of atom. So we have already covered the first session of this lesson where we have discussed about the general structure of atom and who are the scientists involved in discovery of electrons, protons, neutrons. Now we'll go ahead in this lesson and where we will be discussing about the term atomic number. So we know that atom is electrically neutral and we know this why? Because there are equal number of electrons and protons always present in an atom. Neutron doesn't carry any charge. So in totality, the total number of opposite charges are equal. So the neutrality of an atom is maintained. Atomic number is that term which refers to the number of protons in an atom and it is denoted by the alphabet Z. Although I have discussed this in our previous session only, so this is nothing new. It is very easy term to know that total number of protons present in an atom is the atomic number. Atomic number simply represented by the letter Z, alphabet Z, and it is number of protons only. For example, when we are saying an atom of oxygen has 8 protons, therefore its atomic number will become 8. When we are saying that carbon atom has 6 protons, so its atomic number is, that means 6. So in similar manner, at least 1 to 20 atomic number you need to remember. In an electrically neutral atom, the number of protons is equal to the number of electrons. Therefore, in such an atom, Z, that is atomic number, as we have said, is equal to number of protons. We can also say that this atomic number is equal to number of electrons as well. Okay, so number of protons and electrons both are equal to each other. So it will be equal to the atomic number as well. Let's understand another example. Just like the term nitrogen element. Okay, it has 7 atomic number we are saying. By this we mean that it has protons also 7 and electrons also 7. This. And in the same manner, when we are saying for sulfur, it has atomic number 16. So it will be having protons 16 and electrons also 16. So for any you can write and remember in this term. Then similarly, by just like atomic number, we have another term, that is mass number. It is the sum of the number of protons and neutrons present in the nucleus of an atom. It is denoted by the alphabet capital A. So mass number capital A is equal to the sum of number of protons plus the number of neutrons only. So in short, you can write it as A equals to P plus N. So this will constitute the mass number for any element. Just like carbon, atomic number 6, mass number 12. So this is the general representation for any element, particularly here carbon. In the notation of an atom, by notation we mean how you represent it, how you write it. The atomic number, mass number and symbol of any element are to be written in this manner. Whereas in the subscript, you write the atomic number and in the superscript you write the mass number. So symbol of an element, suppose X is the symbol for any element, general representation we are doing. So mass number is represented by this Z in the superscript. Atomic number is represented by Z in the subscript and mass number as superscript and alphabet A is represented. So this is the general representation for any element. For oxygen, you are going to write this. For nitrogen, you are going to write this. For hydrogen, you are going to write this. For helium, you are going to write this. So, for any element, you can represent in this manner. Characteristics of an atom according to the modern concept we'll be discussing now. Atoms of all elements, they are made up of 3 fundamental particles, electrons, protons and neutrons, and except hydrogen. Why hydrogen has this exception? Because it has no neutrons and we have discussed this in our previous session. Hydrogen is represented by this symbol and it has 1 proton and mass is also 1. It has 1 electron also. So we know mass is the sum of protons and neutrons. So when you have to calculate the number of neutrons, you will subtract the number of protons from the mass number. Mass is also 1, proton is also 1, so it will become 0. So that is why this exception is written, that it has no neutrons. Rest all elements have equal, not equal, but a number of particles. All 3 particles are present. The nucleus is the centrally located part of an atom. It contains protons and neutrons. Most of the mass of an atom lies in it. This is because electrons have negligible mass and protons and neutrons are much heavier, contributing to the mass of an atom. So, by this statement we mean this is central part is located as the nucleus. This nucleus is the mass containing for any element which is P plus N only, the sum of protons and neutrons, and electrons are present in this energy shells, the path where they revolve, and these paths have fixed energy. Then electrons are found outside the nucleus. This is the concentric circular path where electrons are revolving and they have fixed orbit. By fixed orbit we mean their energy is fixed. They do not radiate their energy outside their orbit, otherwise they will fall into this nucleus after some time, but that doesn't happen. Stability is maintained, so atom doesn't collapse. Its structure is maintained because of this fixed orbit. Further, nucleus is positively charged because only protons have positive charge present, neutrons have no charge. Electrons are negatively charged particles. So we have here only summarizing the concept for an atom in modern terms. The number of electrons is equal to the number of protons, which means atoms as a whole is electrically neutral. We have all discussed all these things. Atoms differ from each other because of the difference in their atomic numbers. Why? Because they will be having different proton numbers, so definitely their characteristics will change according to the presence of number of protons in them, which is an indication of the atomic number only. Now, atomic mass or relative atomic mass. So, you have learned about mass number. Now, when we are discussing for any particular element, it is termed as atomic mass and it is calculated in relation to some standard. So, that is why it is also termed as relative atomic mass. What is it the meaning of this term? The mass of an atom is known as its atomic mass. Since atom is a very small unit, it is not possible to measure its mass in grams. It has negligible amount of mass. You cannot measure in terms of grams. Like you cannot say just like you measure gold or something or any vegetable or something. So they have particular unit, like to measure bananas, you measure them in dozens, right? But these atoms are very small entities. You measure them in terms of moles. Mole is another entity or the unit of measurement, which you will be learning about this in your higher class. But right now you need to understand that it has very small mass. You have learned that the electron is 1/1837 part of a mass of hydrogen atom. Mass of hydrogen itself is 1 and 1/1837 part will be very less. 9.1 10 per minus 28 grams it is represent. It's a very small unit. So it's a negligible amount of a unit you term for electron right now I said. These electrons are present in an atom only. So an atom totally will be having a very small quantity of mass. Therefore, the mass of these lighter elements or atoms only, like that of hydrogen, 1/12 of carbon or 1/16 of oxygen is taken as the standard unit. So they are measured in terms of either carbon or oxygen. But the mass which you know today are measured in terms of this carbon only. That how much the part of any unknown atom whose mass you are calculating is heavier than 1/12 part of the carbon atom. Mass of an atom of any other element is compared with these standard units. Carbon atom is the most suitable and most widely accepted standard unit for the measurement of atomic mass. So that is why the masses known today are measured in terms of taking this standard. This is the table representing the atomic numbers, mass numbers, relative atomic masses of some common elements from 1 to 20 it is being represented. So you can easily see here hydrogen has atomic number 1, mass number 1, relative atomic mass is also 1 here, lithium has 2, 4. Okay, so relative atomic mass will have some fractional values because in terms of 1/12 of carbon it is being measured. then it is being simplified for calculation purposes here. Okay, so these are the values for which you will be using in calculation parts. Aluminium like 27 it has, silicon has 28, so in this manner. And from this table, most of the masses are just double of their atomic number. Some are different because of presence of their isotopic forms. Atomic masses or relative atomic masses also tell us that how many times the atom of an element is heavier compared to that standard unit, that is 1/12th part of carbon. Like relative atomic mass of sodium atom, it is 23, atomic number 11. This means that an atom of sodium is 23 times as heavy as 1/12th of mass of carbon atom. Earlier atomic mass unit was abbreviated as AMU, atomic mass unit, but now it is being changed, and now according to latest IUPAC recommendation, only U signify as unified mass, only small u is being shown. Then now we'll discuss that how these electrons are arranged in the circular path. So arrangement of electrons around the nucleus of an atom, which is nothing but electronic configuration. Very important topic now, because this is going to form the basis for writing electronic configuration for 1 to 20 elements. And after 20th element, that is calcium, there is another pattern for writing configuration for elements, and that will be dealt in 11th class. But right now from this class only, you are going to learn about writing configuration for 1 to 20 elements. As we have said that central part of the atom is nucleus and electrons revolve in the circular path around the nucleus. These paths are termed as shells, energy shells, because they have fixed energy in which the electrons are revolving. So these shells have been named also. Just like you have a name, these shells also have a name. The one shell which is closest to the nucleus is termed as first shell. Then in successive manners, as it is going farther away from the nucleus, the namings will be changed. 1, 2, 3, 4, 5 and so on. And in terms of alphabet, it is represented as K, L, M, N shells. So K is the first shell, L is the second shell in these terms. Each of these shells contain different number of electrons, which depends on the amount of energy associated with them. The number of electrons that would be present in an atom and in this shell. Okay. For example, we know this is the first shell or the K shell. This is the L shell or the second shell, and this is the M shell, the third shell, right? So there was one scientist we have learned in our previous session, Niels Bohr. In 19th century, he studied the structure of atom and he said that electrons revolve in these energy shells, and the electrons, the numbers that would be present in these shells will be calculated by the formula 2n square. This n is the number of shell, either first, second or third. So when n is 1, so you are going to write 1 in place of n, and it is 1 square, so it will become 2 only. This is for K shell. For L shell, it will become 2 square, so 8, and for M, it will be 3 square, so it will become 18. So it follows a pattern 2, 8, 18, 32 in this manner. These are the number of electrons that would be present in the shells. So from this diagram, you can see that the first shell will be having 2 electrons. Second shell will be having 8 electrons. This is the maximum limit of this shell. And the third shell will be having 18 electrons. So in this manner, you arrange the atomic number of any element, and this will signifies its electronic configuration. The shell closest to the nucleus has lowest amount of energy, so hence contains least number of electrons. So you saw 2 electrons only. The following rules are to be followed for writing the number of electrons. The very first rule I have already explained, that maximum electrons are calculated by this 2n square formula. So on the basis of that, 2, 8, 18, 32 pattern is obtained for the putting up electrons, filling of the electrons in the energy shells. So this is this table representing the filling of electrons in the shell, and it is known as, this formula is known as Bohr-Bury scheme after the scientists Bohr and Bury only. Okay, both have studied this. So see here, hydrogen, one atomic number only. So the first shell, as you saw from 2n square formula, it can have 2 electrons. The maximum limit is 2, but hydrogen has one atomic number only. That means only one electron it needs. So the K shell has only one electron. Okay. Similarly, now see for helium, it has 2 atomic number. So that means atomic number are what? Protons and electrons only. So these electrons are what? 2 only. So K shell will be having 2 only. Lithium now, it has 3 atomic number. So first shell will be having maximum 2 electrons only. You cannot put in K shell 3. From the formula you have already seen. So obviously you will move on to the second shell. So 2 are already justified, only 1 has to be justified. So configuration will become 2, 1. And in terms of atom, you will show in this manner that 2 electrons are present here and 1 electron here in this manner. These circles are the electrons and this is the nucleus. And for lithium atom, we'll see these atomic structure diagram ahead for all the elements. Now, one thing you need to remember here, that after neon, neon has atomic number 10. So its configuration you will write 2 and 8. 8 plus 2, 10. Second shell can have maximum 8 electrons. So till here it is going easy. Everything is justified. But as you move on to this, after reaching this argon, argon has atomic number 18. Its configuration you will write that first shell will have 2 electrons. Second shell can have maximum 8 electrons according to the Bohr-Bury scheme 2n square formula. And third shell, you saw that according to this formula, third shell, M shell, can have maximum 18 electrons. But in order to justify, the rest 8 is left only, no? So you will put simply 8. So 2, 8, 8 for argon. Now when you move on to potassium, atomic number 19, you will not put its configuration as 2, 8, 9. This is the wrong representation. Now you can question that the maximum electrons are 18. So you can put a 9 here. But this is not true. See here, potassium is 2881. Now why this has been done? It is being done because these atoms follow a stability rule also, which is known as octet rule. Octet is for 8. Whenever you have to end the configuration of an atom, that means last filling of electrons when you have to do, you will never end elements other than noble gases for at 8 electrons. Like for neon, you can write 2, 8. For argon, you can end it at 8. Because noble gases are what? They are inert gases, their octet is full, they are stable. Their configuration is fulfilled already. So these elements could be end at 8 and it follows the rule also. But when we reach to potassium, potassium is not a noble gas. So you cannot add this or end the element more than 8 electrons. This octet rule states that you can end for noble gases 8 but not for potassium because it is not a noble gas. So instead of putting the last shell with 8 electrons, the second last shell, that is the shell just after the valence shell, that means prior to the valence shell, there you can put 8 electrons. So that is why this potassium is written in this manner that the second last shell could be having 8. Now we are left with only 1 electron to complete 19. So move that last electron to the fourth shell. 2881 it will become. Second last shell can be written as 8. So it is a exception to that rule 2n square, which states that it can have maximum 18 electrons, but we cannot fill 18 electrons or more than 8. Okay, because it will violate this octet rule. In hydrogen case, in order to make it stable, whenever we are making any element stable, we follow octet rule. That is, we have to end the element at this octet state whenever we have to make any element stable, except hydrogen, because hydrogen is closest to helium noble gas. It is stable by having 2 electrons only. So whenever we have to make this hydrogen stable having 1 electron, we can add only 1 electron and it will become 2 closest to the helium noble gas. So this is when an element is stable by having 2 electrons only, is known as duplet rule. So stability is defined in terms of octet and duplet rule. Duplet rule is only followed for hydrogen. Rest other elements follow octet rule. So from here clearly understand that why potassium has no configuration like 289. It has been written in this manner, and then so on, 2882, 2883, in this manner you will write. So this is the representation for first 10 elements, how the atomic structure with proper electron filling are shown. If the number of electrons in the outermost orbit is 8, just now whatever I have explained is now written here. If the outermost shell has 8 electrons, you call it chemically stable and inert. That means such elements will not prefer reaction with any other element. They remain just like that in their neutral form. But any number less than 8 make it chemically unstable and reactive. So these elements which show reaction, oxygen, hydrogen, potassium, sodium, they all show reaction because they do not have 8 electrons in their outermost shell. They have less than 8 electrons. So in order to become stable, they show chemical reactivity. They react with other elements to become stable. Exception hydrogen, it cannot have more than 2 as it has only one shell. So it follows duplet rule. Electrons are not accommodated in a given shell unless the inner shells are filled. So unless inner shells are completely filled, you will not fill the next shell. Exception is that from potassium it starts, right? The third shell have a maximum 18 limit, but we do not fill it completely. We fill it till 8 only. That is, the shells are filled in a stepwise manner. Now valence shell and valence electrons. So the last shell of an atom, those shells you draw concentric rings, the last shell is the valence shell, outermost shell, and the number of electrons that are present in that shell becomes the valence electrons or the last shell electrons or outermost shell electrons. These outermost shell electrons determines the valency of the element also. How it determines the valency? For example, let's say sodium, 11 atomic number. So we'll arrange its configuration as 2, 8, 1. And let's take the example for nitrogen, 7 atomic number. You'll write its configuration as 2, 5. Now the statements are saying that this valence shell determines the valency of the element. Valence shell is this. This is the last shell. So sodium, it has one valence electron. So its valency is 1, that is why. Nitrogen has 5 valence electrons, but it doesn't have 5 valency. It's a non-metal. So let's understand for non-metals first. Whenever the last shell has 4 or more than 4 electrons, like 5 here, carbon 2, 4. These two are non-metals. So the non-metals, or simply an element having 4 or more than 4 electrons, they prefer gaining electrons to become stable. They will gain electrons, and we have to make them stable by making 8 electrons in their last shell, the octet rule. So 5 will become 8 by gaining 3 electrons. 4 will become stable by gaining 4 electrons. This carbon is completely different, but right now for this valency, understand in this term only. This carbon doesn't gain nor loses electron, but just for understanding of this statement, I am including this example as well, that it can become stable by gaining 4 electrons. It will become stable by gaining 3 electrons. So the number of electrons being gained in order to become stable becomes the valency for the non-metal. Like in this case, nitrogen will have valency -3. Although charge, this sign doesn't matter, but it is only represented because electrons are minus charges, minus has been added, so the term -3 is represented. Sodium has lost its 1 electron, it has lost its minus charge, so its valency is represented as +1. So any element having 1, 2 or 3 electrons in their valence shell, they will have +1, +2 or +3 valency respectively. An Li element having 4 or more than 4 electrons in their valence shell, they will be having valency which is determined by 8 minus the number of valence electrons. So that's how you determine the valency. So with this, we'll wind up the session where we have discussed about the valence electron, valence shell and electronic configuration of atoms. Now we'll be discussing some more important topics from this lesson only, but in our next session. Till then, revise these topics. Thank you so much.